Okay, I hope I'm audible to all students who are attending this lecture for the Delhi School of Economics, MA Economics entrance. We continue with our discussion of the Delhi School of Economics 2021 paper for the MA Economics entrance. And if all students can recall that in the previous lecture, we had done our discussion till question number 3. Now, in this particular lecture, I intend to take up the discussion from question 4 onwards. Okay, so let's read question 4. We need to find the value of summation as R goes on from 0 to 50, 100 CR. Remember, this is the notation we use for combinations. Okay, so let me quickly come to the whiteboard and let's solve this particular question. So we continue with our discussion of the Delhi School of Economics 2021 paper for the MA Economics entrance. And in this particular lecture, we are looking at our discussion from question 4 onwards. Okay, so we need to find the value of summation as R goes on from 0 to 50, 100 CR, 100 C2R. This is the value we need to find out. Okay, now first of all students should be able to recall the formula for combinations. Recall that NCK is equal to n factorial upon k factorial n minus k factorial. Okay, and all students should also be able to recall the properties of combinations which we had done, that NC0 plus NC1 plus NC2 plus ... NCN is equal to 2 to the power n. We have done this property in our lectures on combinations within our mathematical methods for economics course. Okay, so NC0 plus NC1 plus ... NCN is equal to 2 to the power n. Okay, so from this, guys, I can write within this, I can write the first part, that NC0 plus NC2, if I take all the even numbers, plus NC4 plus ... This is going to come out as 2 to the power n minus 1. If I take all the even numbers from 0 to n, okay, and similarly, if I take the sum of all the odd numbers, NC1 plus NC3 plus NC5 plus ... this is again going to come out as 2 to the power n minus. So these are the properties of combinations, 2 properties of combinations. And if you look at this particular question, if I expand this term, so it's going to be 100 C2 into 0 plus 100 C2 into 1 plus 100 C2 into 2, and this is going on till what? 100 C2 into 50. So this is 100 C0, 100 C2 plus 100 C4 plus 100 C100. Now, guys, if you compare this with this, if you compare the two, what do we learn? Clearly, n is equal to 100. Okay, and you can see that these are all even numbers, 0, 2, 4, 100. So my answer is what? 2 to the power n minus 1. This 2 to the power, what is n? 100. 100 minus 1, 99. 2 to the power 99 is my answer for this question. So I'm revising the solution again, guys. Objective was to find out summation as R goes on from 0 to 50, 100 C2R. We have used the properties we had learned in combinations, that NC0 plus NC1 plus ... NCN is equal to 2 to the power n. If I take all the even numbers, NC0, NC2, NC4 and so on till n, it's 2 to the power n minus 1. If I take all odd numbers, NC1, NC3, NC5 till n, we have 2 to the power n minus 1. Again, the sum is 2 to the power n minus 1. That means from 0 to n, if I take all even sums and add them up, it's 2 to the power n minus 1. If I take all the odd terms and add them up, it's 2 to the power n minus 1. So if I expand this, it looks like this. And this, if I compare, my n is equal to 100. And how many terms I have? 100 terms. So it's 2 to the power n minus 1. My sum is 2 to the power n minus 1. N is 100. So 2 to the power 100 minus 1 is 99. So my answer, I can come back to the question paper and we can mark the correct answer. It's 2 to the power 99. This is the correct answer for this question. So hoping all students have understood question number 4. Let's look at question number 5. Suppose that n participants with distinct names arrive for a conference. So all these n participants have different names. No two names are the same. The organizers have prepared the name tags for all of them, but by mistake allocated the name tags randomly to the participants. We need to find out the expected number of participants who will receive their own name tag. So the tags have been distributed randomly among these n participants, and we need to find out of all these participants, what are the expected number of participants who are going to correctly receive their own name tag. So it's a random variable and probability based question. So let me come to the whiteboard and we can solve this. Okay, so quickly writing, first of all, what is given? We are given that there are n participants. There are n participants with distinct names. There are n participants with distinct names that arrive for a conference. We are given this information, and we are also given that the name tags are allocated randomly. The name tags are allocated randomly to the participants. Now the question is asking us to find out what? The question is asking us to find out the expected number of participants. Expected number of participants who receive their own name tag. Expected number of participants who receive their own name tag. So let's quickly solve. First of all, I can define the random variable. So I can say that let xi be the random variable. Let xi be the random variable that takes the value 1 if the ith participant gets its own name tag. Okay, so xi is the random variable which is taking the value 1 if the ith participant has got its own name tag. So for example, if my name is Akshay and I have got the name tag with the name Akshay, then suppose I am the ith participant, my xi is going to take the value 1 because I've got the correct name tag, which is consistent with my actual name. Okay, and obviously it's going to take the value 0 if I get the name tag which is not consistent with my true name. Okay, so what is my objective? Objective is to find out the expected number of participants who receive their own name tag. So we need to actually find out expected value of the sum of the xi's as I goes from 1 to how many participants are there? N participants. We need to find out expected number of participants who receive their own name tag. Okay, so in a way we need to find out expected value of summation xi. What was xi? Xi was taking the value 1 if the ith participant receives its own name tag. So I need to find out x1 plus x2 plus x3 plus dot xn. When I sum them up, I'm going to exactly get the number of participants who have received their own name tag. Okay, so basically I need to find out expected value of x1 plus x2 plus dot 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 xn. Now x1 plus x2 plus xn, these are all linear in xi, so I can write expected value of x1 plus expected value of x2 plus dot 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 expected value of xn. I can write it like this by the linearity of expectations. By linearity of expectations. Also, guys, all of us have done this in our statistical methods for economics course, that expectation of a sum is the sum of expectations. So remember this, expectation of a sum is the sum of expectations. So I can write expected value of x1 plus x2 plus xn is expected value of x1 plus expected value of x2 plus dot 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 expected value of xn. Now, if I find out what is expected value of x1, expected value of x1 is nothing but the value taken by x1, which is 1, into what is the probability of the first participant receiving its own name tag. What is x1, guys? x1 will take the value 1 if the first participant gets its own name tag. Out of n participants, what's the probability that I am getting the correct name tag? 1 upon n. Right? So this is the value taken by x1. This is nothing but probability of x1. When I multiply x1 into probability of x1, what do I get? Expected value of x1. Remember, guys, in general, I can write on the top, expected value of x is what? Summation x into probability of x, right? So expected value of x1 will be the value taken by x1, which is 1. What is the probability that I am receiving my own name tag? 1 upon n, because there are n participants. And for me to receive the correct name tag, the probability is favorable outcome is only 1. There is only one way in which I can receive my own name tag upon total number of ways n, because there are n participants. Plus, what is the expected value of x2, guys? Same, because all these xi's are independent and identically distributed. All these xi's are independent and identically distributed. So expected value of x2 will be nothing but the value taken by x2, which is 1, into probability of x2, which is 1 by n. Similarly, I can keep on adding till the nth term. Expected value of xn will be what? Xn will take the value 1 into what's the probability of xn? What's the probability that the nth participant is receiving the correct name tag? 1 upon n. So basically, guys, what are we doing? If I erase this particular part off, if I erase this off, you can clearly see that 1 upon n is being getting added how many times? 1 upon n is added n times. So if I am adding 1 upon n times, my answer is n into 1 upon n, which is equal to 1. This is the correct answer for this question. So hoping all students have understood. Objective was to find out the expected number of participants who are going to receive their own name tag. We had defined the random variable xi as taking the value 1 if the ith participant gets its own name tag, and 0 if it is not getting its own name tag. So our objective was to find out expected value of summation xi, where summation xi is going to give me the total number of participants who have got their own name tags. So expected value of summation xi will be expected value of x1 plus x2 plus xn. We know that expectation of a sum is the sum of expectations, so it's expected value of x1 plus expected value of x2 plus dot 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 expected value of xn. Okay, then we had found out that expected value of x1 is x1 into p of x1. What is x1 taking the value 1 with what probability? 1 by n, because probability of receiving the correct name tag is 1 upon n. Favorable outcome is only 1, total number of outcomes is n. Similarly, expected value of x2 will also be x2 into p of x2, which is again 1 into 1 by n, because all the xi's are independent and they are identically distributed. And similarly, xn will also take the value 1, and probability of xn will also be equal to 1 upon n. Probability of xn is also equal to 1 upon n. So 1 upon n is getting added n times. That means it's n into 1 upon n, which is equal to 1. This is the correct answer for this question. So I can come back to the question paper and we can mark the correct answer is option C. This is the correct answer for this question. And then let me look at the last question for this particular lecture, after which we stop. Question number 6. A right angle triangle has two equal sides of 1 inch. One of these sides drawn horizontally is divided into n plus 1 equal portions. On each portion after the first, a rectangle is formed with height equal to the vertical distance from the left hand end portion of the hypotenuse of the triangle. We need to find the sum of the rectangle areas and its limiting value. So let's first of all draw the figure for this question. Okay, so let me draw a figure, because a figure is going to give a correct idea about what we need to exactly find out. So first of all, we are drawing a right angle triangle. That is simple to draw. You can see on your screen a right angle triangle. Let's call this as triangle ABC, with angle ABC as 90 degrees. We are given that the two sides are equal and both these sides are of 1 inch each. So this is also 1 inch and this is also 1 inch. And we are also given that the horizontal side BC, remember AB is the vertical, BC is the horizontal side. So we are given that the horizontal side is divided into n plus 1 equal portions. Okay. Now BC is divided into n plus 1 equal portions. Total length is 1 inch and 1 plus n equal portions. So guys, what is the length of each portion? The length of each portion is how much? The total length is 1. Total length of BC is 1. It is divided into n plus 1 portion. So the length of every portion is 1 upon n plus 1. Length of each portion is 1 upon n plus 1. Now the question further says that leaving the first portion, suppose I leave the first portion, then from this point onwards, I keep on drawing rectangles. I keep on drawing rectangles. So for every n plus 1 portion, I am drawing rectangles, right? Now, I am not drawing all rectangles, but you can imagine that after leaving the first portion, this is my first portion which I have left in red color, and then I am drawing rectangles. Now, first of all, what will be, suppose I pick up the first rectangle. So for the first rectangle, what will be the breadth? Breadth is nothing but 1 upon n plus 1 only, because each of these are of 1 upon n plus 1. On the horizontal segment, you can see that the breadth of every rectangle is 1 upon n plus 1. But what is the height, guys? What is the height? You can clearly see that AB and BC both are of 1 inch. And you can clearly see that if you look at this clearly, you can clearly see that if this is a right angle triangle and AB and BC are exactly equal to 1 inch, then what will this point be? This will be n upon n plus 1, because this 1 inch is left. So we are left with n upon n plus 1. Similarly, this point will be n minus 1 upon n plus 1, and so on. So I can say that in general, I can say that for the kth rectangle, if I choose, it will have a breadth of 1 upon n plus 1 and it will have a length of, how much length will it have? If I talk about the kth rectangle, it will have the same breadth, but its length will be k upon n plus 1. Its length will be k upon n plus 1. So hoping all students have understood, because you can clearly see if you look at the vertical part, the horizontal and vertical part both have the same length of 1 inch each. So if I draw another diagram just to show you again, suppose this is from here to here, suppose this is 1 upon n plus 1. Then if I have to calculate the length, what will the length be? What will this length be? Now this whole part is 1 inch, right? This whole part is 1 inch. What will this part be? From what am I losing? I am losing this 1 upon n plus 1, right? So 1 minus 1 upon n plus 1 is how much? It's nothing but n upon n plus 1. So this particular part will be n upon n plus 1. And similarly, I am going till the kth rectangle. So in general, for the kth rectangle, it will have the same breadth, because every time my breadth is nothing but 1 upon n plus 1, because I am breaking down the horizontal part into n plus 1 equal portions. So every time my breadth is 1 upon n plus 1. But if you look at the height is dropping by 1 every time. The height is dropping. You can clearly see initially the height was 1. Now it's n upon n plus 1. Okay. And then if you further go for the second rectangle, you can clearly see it's even going to further go down. Okay. So it's going to be n upon n plus 1 minus 1 upon n plus 1, which is n minus 1 upon n plus 1, and so on. Okay. So if I talk about the kth rectangle in this particular case, the kth rectangle will have the length of k upon n plus 1. Okay. So now what is the area? Area of the kth rectangle is nothing but length into breadth. Length is k upon n plus 1. And the breadth is 1 upon n plus 1. So length into breadth gives me my answer as k upon n plus 1 square. This is the area of the kth rectangle. Okay. I can also make a small correction, guys. Suppose I talk about, I'm starting with the nth rectangle first. You can clearly see for the nth rectangle, which is my first rectangle I'm making, the breadth is 1 upon n plus 1 and the length is nothing but n upon n plus 1. Okay, I am drawing the picture again so that all students get a perfect clarity about this. I am drawing the picture again so that there is no confusion with the students. Suppose this is my right angle. This is my right angle triangle. Okay, and the sides are of 1 inch each. Okay, and I am drawing rectangles. Okay, leaving the first one. So you can clearly see the rectangle which we are drawing. Okay, these are all rectangles, and how many rectangles can I draw? So if you clearly look at this, the 1 inch portion is divided into how many equal portions? It is divided into n plus 1 equal portions. This whole lot is divided into n plus 1 equal portions. And leaving the first one, how many rectangles are there? N rectangles. There are n rectangles in total I can make. Because I'm leaving the first one. In the question, it's clearly mentioned that leave the first one. So if I talk about this being the first rectangle, second rectangle, third, fourth, fifth, this is my nth rectangle. And you can clearly see the length of this rectangle is how much? The breadth is how much? Let me correct myself. The breadth is 1 upon n plus 1. All these rectangles are going to have the breadth equal to 1 upon n plus 1 because this 1 inch, which was the whole horizontal part, was divided into n plus 1 equal portions. But if you look at the length, all the rectangles are having the same breadth. The breadth of the length of the nth rectangle is n upon n plus 1, as we have seen, because this horizontal part, this vertical part and this horizontal part are the same. So if how much will this part be? This part will be the whole 1 inch. If I have to calculate this part will be the whole 1 inch minus leaving out this small portion, which is 1 upon n plus 1. So this is going to be n upon n plus 1. That means for the nth rectangle, my length is n upon n plus 1. So for the kth rectangle, it's going to be k upon k plus 1. I hope now all students are clear. The nth rectangle is having a length of n upon n plus 1. So kth rectangle will have a length of k upon n plus 1. The breadth of all the rectangles remains the same, is 1 upon n plus 1. So now the area of the kth rectangle is length into breadth, which is k upon n plus 1 into 1 upon n plus 1, which is k upon n plus 1 ka square. Now I need to find out the sum of the areas. So if I erase all this off, now the objective is to find out the sum of the areas and its limiting value. So first of all, let me find the sum. So sum of the n rectangles will be summation as k goes on from 1 to n, because we have picked up the kth rectangle. So summation as k goes on from 1 to n, k upon n plus 1 ka square. The area of the kth rectangle is k upon n plus 1 ka square. Since I need to find the sum, I need to add this term as k goes on from 1 to n. Remember, k upon n plus 1 is the area of the kth rectangle. I need to find out the sum of the area. So I need to find out the sum as k goes on from 1 to n, because we have n rectangles, k upon n plus 1 square. So guys, k is a constant. Okay. Sorry, k is not a constant. N plus 1 square is a constant. So constants come out of the summation times summation as k goes on from 1 to n k. K is a variable, but 1 upon n plus 1 ka square is a constant. Constants always come out of the summation. Okay. So if I erase this part off, so I can write this. Therefore, Sn is equal to 1 upon n plus 1 square times summation k as k goes on from 1 to n is 1 plus 2 plus dot 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 n. What is the sum of the first n natural numbers? We know that the sum of the first n natural numbers is n into n plus 1 by 2. N plus 1 cancels with the power here. I get n upon 2 times n plus 1. This is my Sn, guys. I'm again revising how we got Sn. Sn is nothing but the sum of all the n rectangles. So it's summation as k goes on from 1 to n, k upon n plus 1 square. N plus 1 square is a constant. It comes out of the summation. Inside we are left with k. You are adding k as it goes from 1 to n. So 1 plus 2 plus n. Sum is nothing but n up into n plus 1 by 2. That's the sum of the first n natural numbers. N plus 1 cancels with the power in the denominator. We get n upon 2 times n plus 1. Now our job is to calculate its limiting value as n tends to infinity. So we need to see that as we keep on adding more rectangles, what will the sum go to? So I need to find out the limiting value. How do we calculate the limiting value, guys? The limiting value is nothing but limit as n tends to infinity Sn. Limit as n tends to infinity. What is Sn? At the bottom of the screen, we have calculated it's n upon 2 times n plus 1. I can bring 2 outside the limit. It's a constant. So half comes out. In the numerator, we have n. In the denominator also, I can take n common. So I get 1 plus 1 by n. This 2 I have taken outside the limit. N plus 1 may I take n outside. So I get 1 plus 1 by n. N and n cancel. My job is to put n as infinity now and check out the answer. So erasing this part off, I can write that therefore this will come out as half times 1 upon 1 plus 1 upon n is infinity. Anything upon infinity gives you 0. So this is 1 upon 1 plus 0. This is half. This is the final answer for this question. So I can write, guys, the answer is the sum of the n rectangles is n upon 2 times n plus 1. And the limiting value is half. This is the final answer for this question. So I can come back to the question paper and we can mark the correct answer. The limiting value is half and the sum is n upon 2 times n plus 1. This is the correct answer for this question. So students, this is where I intend to stop in this particular lecture. Again, the objective was to discuss a few more questions in order from the Delhi School of Economics 2021 paper for the MA Economics entrance. In the next lecture, I will be starting with the discussion from question 7 on. So I hope all students have enjoyed this lecture. Any doubt, you can unmute your mic and ask, or call up or mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.